At time t seconds, where t is greater than or equal to 0, a particle p moves so that its velocity v meters per second is given by v equals 6ti minus 5t to the power of 3 over 2j. When t is equal to 0, the position vector of p is minus 20i plus 20j meters. And part A wants us to find the acceleration of p when t is equal to 4. So first of all, if we find some way to link velocity and acceleration, this would be a good start because we have an expression for velocity up here and our answer is to do with acceleration. We want to find the acceleration of p. So as a general rule, we know that velocity is equal to the integral of acceleration. And therefore, if we reverse that, acceleration is equal to the derivative of velocity, so dv by dt. So if we went to find this, we would want to differentiate this expression up here. And so for 6t, we do the coefficient of t, which is 6, multiplied by the power, which is 1. So 6 multiplied by 1, and then we take away 1 from the power. So we're left with 6t to the power of 0, which is just 6. And then we keep the I just constant. We don't do anything to the I and the j. And then we do the exact same to the next term. So this becomes minus 15 over 2t to the power of a half j. And now we have our expression for the acceleration. But the question's not asking for a general expression for acceleration. It's asking specifically when t is equal to 4. So if we want to find the acceleration at t equals 4, we just substitute in t equals 4 into our equation. So we have a is equal to 6i minus 15 over 2 multiplied by 4 to the power of a half j. And this turns to acceleration is equal to 6i minus 15j meters per second, because remember it is acceleration, so we do give units, and that's the question. So the 3 marks for this question, the first 2 actually come from differentiating, because we get a method mark just for knowing to differentiate v, and we get a further answer mark for differentiating correctly. So this would give us 2 marks as we've differentiated and we've got the right numbers, and then we get our last answer mark for actually getting that the acceleration is 6i minus 15j meters per second squared. Now part B wants us to find the position vector of p when t is equal to 4. And position vector is to do with distance, or we could call displacement. And the relationship between velocity and displacement is that velocity is the derivative of displacement. So v is equal to ds, we denote displacement with an s, ds by dt as a general rule. So therefore, displacement is the integral of velocity. So if we were to find the displacement, which is what we'd need to do to find the position vector, we would integrate the expression for velocity, which is 6ti minus 5t to the power 3 over 2j. And we would integrate this. And when we integrate things to do with I and j, we leave the I and the j alone, just as we did for part A with the differentiation. So first of all, for 6t, we add 1 onto the power and divide the 6 by it. So 6 divided by 2 is 3t and then squared I. And then same for the next one, adding 1 to the power. So 5 divided by 5 over 2 gives us 2t to the power of 5 over 2j. And then because this is integration, we need a plus c. But the difference with integrating vectors is that the c is also a vector. And when we find what c is, which is what we're going to need to do in a minute, c will have an I and a j term involved with it. So now we have this expression for the position vector of P, but we don't know what C is, and that's what we need to find now. So if we go back to the question, we're told that when T is 0, the position vector is minus 20i plus 20j. And given that this is our expression for position vector of P, we can substitute in T equals 0 to try and find C. So at T equals 0, we know that this whole expression should equal minus 20i plus 20j, because that's what we were told in the question. And because this term here and this term here are all multiplied by 0, we get that C is equal to minus 20i plus 20j. Now, if we include that in our original expression, but we substitute in that C is equal to minus 20i plus 20j, and if we factorise them by the I and the j terms, just to make it easier, we have 3t squared I minus 20i. So if we write this as 3t squared minus 20i, and then do the exact same thing for j. So we have plus 20 minus 2t to the power of 5 over 2j. We now have our full expression for displacement, or the position vector. Now again, we want to find the position vector at t equals 4. So if we substitute this into our expression at t equals 4, we get that this is equal to 3 multiplied by 4 squared minus 20i plus 20 take away 2 multiplied by 4 to the power of 5 over 2j. And when we put this into a calculator or work it out, we find that the displacement, and therefore the position vector of P at the point t equals 4, is 28i minus 44j. And this is all in meters, because again, we're measuring a direction displacement, which is measured in meters. Now, this question was also 3 marks, and our first mark came from integrating the equation for velocity, which we've done up here. And then we got a further answer mark for doing this correctly and getting the right numbers, the numbers they have in the mark scheme. And then last of all, we get an answer mark for actually finding that the position vector at t equals 4 is 28i minus 44j meters.